This lesson is for advanced algebra. We're going to do lesson 10.4 on trigonometric functions. We're also going to do 10.5 in the same video. 10.4 is on trigonometric functions, also referred to sometimes as circular functions, and the ones we're going to focus on today are sine and cosine. We're going to put those on something called the unit circle. It's called the unit circle because the r value is going to be equal to 1, meaning the radius of the circle is a 1. So let's just draw a quick circle, or actually maybe we can go to a separate unit circle here, and we're going to start to fill in some coordinates on this circle with the assumption that the radius of it is still a 1. So pretend that this length here is a 1. This coordinate is always where we're going to start when we go on the unit circle. So think about it like a clock. We're always going to start at 3 o'clock. When we travel around the circle, we're always going to go in a positive direction, which would be counterclockwise. And if the radius is a 1, that means that this coordinate on the actual circle is located at the point 1, 0. And we're going to make that our starting point, so we're going to call that 0 degrees. If you travel 90 degrees in the counterclockwise direction, that's a quarter of the way around the circle, so you're going to end up here at 90 degrees. Again, if the radius is still 1, then this coordinate on the circle is located at 0, 1. If we continue to travel around the circle counterclockwise another 90 degrees, we're going to end up at 180 or 180 degrees, and that coordinate's going to be at negative 1, 0. Continuing around the circle, if we end up at the bottom at 6 o'clock, we'd end up at the point 270, which is the coordinate 0, negative 1. And then by the time you return back to your original position, you've gone a total of 360 degrees. What I'd like students to do next is just kind of focus in on quadrant 1 here. Do a quick review on the quadrants. This is quadrant 1, and then again as you go counterclockwise around the circle, this is going to be quadrant 2. Down here this is quadrant 3 and quadrant 4. And let's just quickly write in the characteristics of all those quadrants. Quadrant 1, everything is positive, so we'd say positive, positive. Quadrant 2, the x values are negative, but the y values are positive. Down in quadrant 3, everything's negative, so we just say negative, negative. In quadrant 4, the x values are positive, but the y values are negative. So I want students to focus in on quadrant 1 for a moment. We're going to return back to our notes. Pretend that we zoomed in on quadrant 1. And so just draw a big quadrant 1 and just that part of the circle. If we're trying to find any coordinate on the circle, not just the ones at the north, south, east, and westernmost points, or what I call the compass points, there's other coordinates along that circle that we can find. So if we're trying to find, for example, the location of that coordinate on the edge of the circle, we could just draw a radius, which we know is going to be a length of 1. And to get to that, we know that we're going to have to go a certain horizontal distance to get there and a certain vertical distance to get there. So the horizontal distance we'd measure with an x value, and the vertical distance we'd measure with a y value. And so what you see there is that we're forming a right triangle. So now we can use our SOHCAHTOA skills that we learned in a previous lesson on how to find the x and the y values. So let's talk about finding the cosine of, and what angle did it take us to get there? Well, usually the angle measurement is given with a new symbol called theta. Usually when the angle is missing, we use this open circle with a line through it, and it's pronounced theta. So if we rotate from our starting point and we rotate counterclockwise to this point, if we do cosine of that angle, we would do, because of how cosine behaves, we know it's going to be a ca situation, meaning adjacent over hypotenuse. We would need the adjacent side, which in this case would be the x, over the hypotenuse, which we know is a 1. X divided by 1 is simply x, so if we want to find the cosine of the angle, that would be the x value. How about the sine? If we did the sine of the angle, excuse me, again we would need to know how far we traveled to get there, and then the vertical component would be the y value. If we're doing the sine, we would need the opposite leg and the hypotenuse side. The opposite leg to the angle is side y, and the hypotenuse again is still 1. So if we do y divided by 1, that is simply the y value. So if we're trying to find a coordinate on the circle when the radius is a 1, the cosine is always going to give us the x value, and the sine of the angle to get there is always going to give us the y value. So let's write that on our circle. So when you're working with the unit circle, meaning the radius is 1, the cosine of the angle is always going to be the x part of the coordinate, and the sine part of the angle is always going to be the y part of the coordinate. And so this is how the book describes those situations. Every coordinate on the unit circle, everything on that circular edge, is in the form cosine theta comma sine theta as a coordinate, and that coordinate is the image of the point 1, 0, because that's our starting point, under a rotation of magnitude theta as we travel around the origin. So every coordinate on this circle, as we start here and maneuver counterclockwise, is going to be in this format of cosine comma sine. So we can use that to our advantage to find values for sine and cosine, like these. If I ask you to find the cosine of 90 degrees, you would imagine the unit circle, you'd figure out where 90 degrees was, hopefully you know that it's here, and we'd grab the x value at that spot because that's what the cosine is. I know that that coordinate is at the point 0, 1. The cosine or the x value is 0. So the cosine of 90 is 0. We can do the same thing with sine of negative 180. Now if a positive direction around the circle is counterclockwise, a negative direction around the circle would be clockwise. So if I think about where I am on the circle, if I travel from here negatively around 180, I'm going to end up at the same spot as if I would if I went positively around to 180. Remember that that coordinate at 180, or negative 180, is the coordinate negative 1, 0. The sign there is the y value, so that would also be a value of 0. Now on the next one, it's sine of 630. So that means we've gone around the circle multiple times. So what we would want to do is subtract any extra rotations around the circle. And so when we subtract 360, we get 270. So finding the sine of 630 is the same as you finding the sine of 270. Hopefully you remember that 270 is way down here at 6 o'clock. The sine or the y value there is going to be negative 1. Let's try one more question. When you have a negative, very similar to what we did up here, only now this time we've gone around multiple times. So we're just going to pretend for a moment that it's positive 900, and we're going to take away any extra rotations. So when I subtract 360 one time, I end up with 540. That means I need to take away 360 again because I've still gone around the circle multiple times. So when I take away 360 again, this time I end up with 180. Now remember, this number was originally a negative, so when I do the cosine of negative 900, that's being in the same position, or going to be in the same position, as cosine of negative 180. So if I think about where that's going to be in the same spot as this one, only now I need the cosine value, or the x value. So I would say negative 1 there as well. Another type of question that you're going to run into is a question that's worded like this. And I didn't mean to cover that up. That should say 70 there. So the book may ask the question this way: what are the coordinates of the image of the point 1, 0 under a capital R stands for rotation, and then the number that's the little subscript tells you your degree measure. So if you rotate 70 degrees starting from this point, hopefully you can imagine that that would be somewhere along quadrant 1. So it's going to be around somewhere right here. So to find the actual coordinates, we would need the cosine at 70 and the sine at 70. So if you had a graphing calculator available, you'd go ahead and type that in. And you'd end up with a set of decimal answers for that, but I'm fine with you leaving it like that because most of the time you won't have a graphing calculator or scientific available here. You could just leave it as cosine 70, sine 70. Just make sure that those are clearly indicated in degrees. We're going to go a little bit further with the unit circle. Now we're going to transition into lesson 10.5. If students would like, they can pause the video right now and go ahead and copy these two pictures. I took these right out of your textbook, page 687. It's a lot of the same information as what we already covered on the unit circle, but it's just kind of laid out in a new way. So if you want to, you can pause the video right now and copy the information. So the information clearly reminds you of the quadrant names 1, 2, 3, and 4. It reminds you as well that in quadrant 1 all the values for theta are going to be between 0 and 90. In quadrant 2 all the values of theta on the circle are going to be between 90 and 180. In quadrant 3 all the values for theta are going to be in between 180 and 270. And finally in quadrant 4 all the values for theta will be between 270 and 360. And then here they've indicated again with the positives versus the negatives. Since the cosine is the x and the sine is the y, anytime you're in quadrant 2 the cosine will be negative but the sine will be positive, and so on. The next thing that the lesson talks about is from page 667, and it talks about exact values. And we're going to use the unit circle to do that. We need to quickly revisit though from geometry class a few years ago, the 30, 60, 90 triangle as well as the 45, 45, 90 triangle. The relationships among the sides of these two triangles are always going to be this relationship. The shortest side is always going to be half as long as the hypotenuse. And so when these relationships exist, we can utilize those and our knowledge of SOHCAHTOA to come up with exact values for sines and cosines. So if you actually went ahead and did the cosine of 30 degrees, you would do adjacent over hypotenuse, and you'd end up getting square root of 3 over 2. If you did it for a 45-degree angle, you would end up with square root of 2 over 2 as well. So we're going to just take these values from these triangles and we're going to put them onto the unit circle itself. So let's go to our unit circle. And the first measurement here, or the first click into quadrant 1, is going to be a 30-degree angle. The next one's going to be 45, and the next one's going to be 60. Now I want to make real clear with students that this angle measure has not been drawn accurately. I did not draw this with a protractor. This was literally just sketched. So you have to imagine that this is a 30-degree angle and that the space here was 15, 15, and 30 again. So we're going to go ahead and put in the exact values now. The coordinate here at 30, if you do the cosine first, it's going to be square root of 3 over 2 and 1/2. Now before we do the rest of quadrant 1 here, well actually let's go ahead and finish quadrant 1. So the 45-degree angle, when you do the cosine and the sine there, you get square root of 2 over 2 for both the cosine and the sine. And then for 60, when you do the exact values for cosine and sine, they end up being the reverse image of the 30-degree angle. So the cosine is 1/2 and the sine is square root of 3 over 2. Now that seems like a lot of information for students to have to maneuver through, so I want to help you build the rest of the circle just using these 3 coordinates and their counterparts. So this pattern of 30, 15, 15, 30 is going to continue as we go around the circle. So let's go ahead and label. 30 degrees past 90 is going to be 120. 15 degrees past that is going to be 135. 15 degrees past that is going to be 150. Then again, we have a jump of 30 degrees there, so that's why we get to the 180. Then the pattern continues. So 30 degrees later is 210. 15 degrees later is 225. 15 degrees later is 240. Then we have another jump of 30 to get to the 270, another jump of 30 to get to 300, 15 to get to 315, and the last one is 330. Now the coordinates that we used in quadrant 1 are going to correspond to all the other coordinates that we just labeled out with degrees. So let's start with the 30-degree angle. If we reflect that coordinate over the y-axis, it's going to match up with the 150. So that coordinate and the 30 are going to share the same values. It's going to be square root of 3 over 2 and 1/2. The only difference is because you're in quadrant 2, the cosine needs to be negative. Let's take that coordinate now and flip it over the x-axis. So that one's going to connect with 210. So 150 and 210 have the same coordinate as well of negative square root of 3 over 2 for cosine. And now because we're in quadrant 3, the sine has to be negative as well. Then we flip that coordinate back over the y-axis and it connects to 330. So that one's going to be square root of 3 over 2. Now that we're in quadrant 4, the x value will become positive and the sine value or the y value will become negative. So I encourage students to memorize those 4 as a group. Start with 30, get that coordinate of cosine first, sine second, memorized, and then just attach in your brain the fact that 30, 150, 210, and 330 all go together. Those are the ones that hug or are closest to the x-axis, so all of those are going to start with square root of 3 over 2 for cosine and half for sine. Let's jump up now and do the 60s next. The ones that go with 60 are the ones that hug the y-axis. So 60 goes with 120. So 60 is 1/2 for cosine, square root of 3 over 2 for sine. So the 120 is going to have that same structure of 1/2 for cosine, square root of 3 over 2 for sine. But now that we're in quadrant 2, the 1/2 needs to switch to being negative. Those two coordinates are going to connect with 240 and 300. So again, what you're going to have is 1/2 for cosine, square root of 3 over 2 for sine. And then you just have to pay attention to your negatives. In quadrant 3, they're both going to be negative. In quadrant 4, only the y value will be negative. And then those two get connected as well. Those are, I think, a little bit easier to memorize because 60, 120, 240, and 300, those all divide evenly by a 6, so those all kind of coordinate that way. The last one you need to look at is really easy. All the 45s connect with all the middles of each quadrant. Another characteristic of the middles of each quadrant is that they all have a 5 at the end. So 135, 45, 225, and 315, those all go together. And they're all going to be square root of 2 over 2 for both cosine and sine. Again, all you need to worry about is whether or not it's positive or negative. So for 225, both the cosine and the sine will be both negative, and those are going to get connected as well. And then we connect that to 45 in quadrant 1 and 135 in quadrant 2. So the last one we need to fill in is square root of 2 over 2 and square root of 2 over 2 for 135, making sure that the x value is indeed negative. So now that we've got this circle filled in, students need to get comfortable memorizing kind of all the purples together, all the blues together, and all the greens together. Now let's put those into practice with some actual questions. So if you're asked to find the exact value for cosine of 315, first thing you're going to think is that cosine is an x value, and 315 ends in a 5, so I know it's going to be square root of 2 over 2. The only other thing I need to worry about is whether or not it's going to be positive or negative. The cosine at 315 is in quadrant 4. Since it's the x value in quadrant 4, I know it's going to be a positive result. If we jump next to the same type of question, find the exact value for cosine of 135. Again, it ends in a 5, so I know it's going to be square root of 2 over 2. 135 is past 90, but not quite to 180, so that's going to be in quadrant 2. The cosine is the x value. X values in quadrant 2 will be negative. Sine at 330, now we're switching to a y value. The sine is always going to be the y value. 330 is the last piece of the unit circle before you get back to the original starting place. So I know that this is going to be matched with finding the sine of 30, but it's going to be a negative number because it's in quadrant 4. So I know that the sine at 30 is 1/2. And so the sine at 330 is going to be that same number, just with an opposite sign in front of it. And then we've got sine of negative 135, so you have to think about where that's going to go if you go around the circle clockwise. Normally, to get to positive 135, I would start here at 3 o'clock. I'd travel through one quadrant and then halfway through the next. Let's do that same thing now, but going the other direction. If I start at my starting point, travel through one quadrant, and then halfway through the next, I'm going to end up at the sine of 225. I know that that ends in a 5, so I know it's going to be square root of 2 over 2. Since I'm in quadrant 3, I know that that value will indeed be negative. Again, you might run into situations where you've gone around the circle multiple times, so you'll just take away any extra rotations by subtracting from 360. So if we do 960 minus 360, obviously there we get 600. And then if we take away additional rotations again, if we take away another 360, we get 240. So I know that that's the third or last click in quadrant 3, and I know that that's going to match with 60 in quadrant 1. So the cosine at 60 I know is positive half, but now that I'm in quadrant 3, I know it's going to be a negative half. The last type of question that students are going to encounter related to the unit circle is when they have to show or draw why the sine at 222 is the same as negative sine 42. So I'm going to go ahead and give that a quick sketch. I'm going to draw my circle. 222 is going to be somewhere in quadrant 3, not quite halfway there. And 42 is going to be somewhere in quadrant 1, not quite halfway there either. Those look like they are 180 degrees apart from each other, so they should essentially be equal. However, when I'm at the sine of 222, I know that that value is going to be negative, and I know that the regular sine of 42 is going to be positive. So the fact that they put a negative sign in front of that is going to force this into becoming a negative value. So now I know that those will indeed be equal to each other. So I just draw a line to show that they are across from each other on the circle. One's negative and the other one was positive, but now we're going to make it negative, so now they will indeed be equal to each other.